Good morning. So this is my first developer conference. I'm used to going to database conferences, and could you imagine my fear right now? A room full of developers on a developer conference, but I see you're human, like me, and I'm getting you're scared at this databases, the black box where we put stuff. Magically it comes back. So hopefully we have an equal amount of fear. Sadly, mine got slightly worse when I heard, oh, do you know where the session about SQL Server on premises is? Nowhere. Oh, room naming. So welcome to Nowhere and this session about SQL Server on premises and why you should use it. Always. No, just kidding. Not always. Sometimes. So, my name is Mikael. I've been paid to do SQL Server database stuff since mid-90s. That is the 1900s. And it's starting to get slightly scary, but that is life, right? One of my best achievements is the scuba diver instructor. But sadly today, you cannot expect a deep dive into SQL. Gothenburg joke, sorry. So, why do SQL servers still live? This is an amazing slide. Don't you agree? This one. That is the suggestion from PowerPoint Designer when it sees the word old. Cool. I'm not a PowerPoint guy. So we're going to discuss why SQL Server lives on premises still. Why does it exist? And we will make sense of most cases where it should exist, and of course some cases where it might not exist. And as always, raise your hand if you have questions. There are two types of questions. There are good questions, which I'm going to answer later, and there are excellent questions that show up on the next slide. So, let's begin. So, a poll. How many recognize these? Hand up. Yeah, exactly. This is maybe the biggest reason we still have the installation of SQL on premises. Because we have run this for ages and it works. Or the other one, don't touch it, it works. We all recognize that and it is true, it works, don't touch it. But you might get some issues, you might get some other things here. So I'm going to focus on the middle point. Do we have a server? I was on a company. They had performance issues with their database server, their financial system. So they sent invoices every day. They entered bookkeeping stuff into the financial system. Two guys were working in the financial system, and random occasions, the system stopped working. Sometimes for a day. And I wouldn't call that a performance issue. The system is not responsive for a day, but they called me in for performance tuning. And we realized when tracking the days, because they've kept track of days, system stopped working. Those days accidentally coincided with the days the boss was on a business trip. You know where I'm going, right? So, he started as the sole owner of the company, had the bookkeeping system installed on his laptop with the database server on his laptop. Imagine the backup frequency of this. So, when he took his computer on a business trip, the server was gone. Do we have a server? Yes. Probably, hopefully, you will know that you have a server, but sometimes you don't even know it. There are tools to discover SQL servers, and I haven't yet been to one company that says, we have 15 servers, and 15 servers show up. It's at least 16. And they say, oh yeah, this one, we forgot about that. So, what is the issue with this? This one. Mean time between failure. Why should we move to the cloud? Because then we don't have to worry about mean time between failure, because that is covered for us in the cloud. And this means that your hard drive has a lifetime of, let's say, 12 months. Today is November 9th, so you can safely run your computer on your hardware to November 8th, 2023. That's how it works, right? Then on November 9th, all the drives will break at the same time. Yeah. I've had a customer asking me this. Could you give me the date when we need to go to the cloud? When is the hard drives failing? And I told him, they can work for 5 years. They can work for 10 years, but they can also fail tomorrow. Over the globe, this is the average failure time. Do you want to bet that your drives are better, not the Monday drives? That is actually a counterpoint to go to the cloud, right? When we go to the cloud, we have a secure environment that somebody else is making secure. Good. So now to the real stuff. I have been in several projects. I work on premises, I work in the cloud, and this session is actually samples, project samples, descriptions, and issues that I've had in projects that ended up being on premises. And this is one of them. Anybody knows what this is? CNC, it's a drill. It's a machine that makes big holes, like this big. It spins with 3,000 rotations per minute. That equals roughly 50 per second revolutions. Calculation, brain, hard, but 20 milliseconds to make one revolution of a drill. So the requirement here was, what if all of a sudden the measures from this PLC system gets higher? The energy consumption gets higher. That is an obvious sign that something got stuck. When it got stuck, it drags around the edge for a very long time. So the requirement was, in the beginning, we should read 1,000 hertz, 1,000 values per second over 34 channels. To find consumption, to find coolant temperature, a lot of stuff to calculate how does this machine work right now. And then within 100 milliseconds, 5 laps of the drill, send an emergency stop to the machine. Cool, huh? So this was the requirements, and well, they changed. Because somebody figured out, oh, we can do FFT analysis of the data. So we can find frequency and tweaks and noises. So we need to have at least DVD quality or CD quality of the sound. Okay. So this was a factory. This is a real factory. And they said, well, we have 17 machines. We need to get them into the same database, of course. And by the way, anybody calculated in the brain or with a calculator how many turns of the drill 100 milliseconds was? 5. Could you imagine something very hard inside a hole going around 5 times before you even can get the signal in. So, of course, we needed to go down to below 30 milliseconds. Did it work? In Azure, as you will see, no, it didn't work, because the latency in Azure is kind of higher than 30 milliseconds just to do the round trip. So, anybody want to guess what is the technology we had to do to get this performance? In memory tables, a good guess. But the interesting thing is we didn't even need that. Optimizing the normal on-disk tables was enough to keep this data going into, of course it was some setup with a bunch of disks. There was only not one C colon with everything on it, but it still worked. We didn't have to go to in-memory tables. That would be the next level of performance to do this. So we went down to below 10 milliseconds in response time. And when we tried to move it to the cloud, we were back to 250 milliseconds of response time on this. So when you need this performance, this fast responses, machine communication, then you would need the database very close. And when we're talking very close, we are talking the database server was not in the data center in the next building, literally across the street. The database was inside the factory, physically on the network, to get the latency down as much as possible. So that is one of the nice reasons to have a SQL Server on premises. And of course, you have a different amount of database products. You have SQL Express that is limited in performance. But if it is latency you need, you can imagine putting one SQL Express on each machine to get even lower latency, worse performance volume-wise, but latency would be a very good number when you get closer to the machines. So, next project. The legacy applications. We've done this forever. No, I'm not from Norway. This was tested in Sweden, and the Sweden Central is situated in Staffanstorp, not so far from here. But anyway, at this specific time, the Norway East was faster, latency-wise. Only 3 milliseconds. But considering the last project, 3 milliseconds is a third of the requirements to get this working. And I would get the West Europe here isn't the best option for us. I let the site name stay here, Azure Speed Test. That is a good, it tests not the latency to the entire Azure, it has storage containers, so we are testing file access to some kind of storage. But it's at least an indicator of how fast this region is to your current location. And this changes, so when you go home, you will get other numbers than you get when you're here. And those legacy applications, well, some work, some don't, because of the latency. And the problem is here the pattern of programming, pretty much. Some latency applications, or most latency legacy applications, aren't made to be somewhere else. They are tightly coupled to their database or to their backends. And when they start to do chatter back and forth, you add this number to every call. We had a customer once who created a nice application, a really nice sales helper application. So when you did a sale, as a sales guy, you went into the application, I am searching for parts. And they sold complex stuff. Non-disclosed what, but they sold stuff. So I'm searching for stuff. And they got a list of maybe 200 parts that this stuff was built from. And that was the order. So when you said, I want to buy, let's say I want to buy a car, then you are getting a list like this long with one wheel, steering wheel, seat belts, seats. So you can build your own car basically like a Lego, but they built it for you. And in their infinite wisdom, they made a list in the application, and for each part in the list, they made a request getting the part information. 200, 500. Did I tell you it was an American company? So of course their server was in the US. 200 parts. That is latency of 2.5 seconds only for getting the smallest component they had. And could you imagine? I'm a sales guy. I'm searching this one. Yeah, result. And that was 2 seconds. Normally, they were working 5, 6, 10, 100 guys at the same time. Yeah, finally. So it was seriously annoying. And what could you do about this? Cache it locally, yes. That was actually a plan. They wanted to cache it locally, so they sent this to Azure, did geo-replication, read-only cache in Europe. But wait, when you place an order, are you placing it read-only? Or do you have the right latency of this one minus one, this one minus one, that goes to the US anyway? So it's fast to search, it's fast to find how the order should look, and then it took somewhere between 10 and 30 seconds to place the order due to the latency, because writes can't be cached locally. Do you recognize some kind of component that has this built in? We're getting there. Now we're talking, right? This is my favorite subject. When I put the DBA hat on, everything is the developer's fault. You know why? Because at every single time there is a performance issue, it's the database. So keep the blame game, go back to the developers. But sadly, there is a bit of truth in this. This is a normal database. This is a small, tiny database. And as everybody knows, we have the wonderful helper, entity framework, and Hibernate, Dapper, whatever. Really good stuff. And that is part of my life, making money from companies that use said frameworks and they had bad performance or bad latency, or the cache server gets out of memory. We have 5 terabytes of RAM and the cache server goes up in the roof. Yeah? Why? Well, because of those two. Let's begin with lazy loading, because that relates to the previous slide. Remember? That relates to latency. Lazy loading means that when I get the customer information and I want to see the order history, the lazy loading will, in the best of worlds, do one query to get all the orders. In the worst of worlds, let's say the older versions of Entity Framework, will make one query for every customer order to get the information of that order. Orders contain details, one, oh, I've already done this order detail. I don't care. It's on this order too. So new query, get this again. A crazy latency. So we solve this how? With eager loading. That means that when you do the first customer, if you do this wrongly, of course, when you do the first customer, the model says, oh, they are probably going to see more customers and more details and more information, maybe even statistics and things. So we're essentially doing a select star with extra everything, downloading the entire database, caching it locally in our memory in Entity Framework. And then we wonder, why does it take half an hour to start the application? Initialize. So somewhere in this is my point. Everybody has a brain. Use it. Because this is common sense. What do you do normally in chunks? What do you look at in chunks? Try to do those things in chunks. So instead of looking at all customers, all orders, all details, you say that, okay, to show this first page of one customer, I enter the customer ID and the sum of the orders of the 5 latest orders. Create that smart query. Boom, gets back immediately, and your user has a result in less than half a second or even less than milliseconds. They are happy, and while they look at, whoa, what happened on the screen? You have time to read details, stuff in the background, so you don't have to worry about the latency. Again, this is if you have the knowledge and the possibility to change the data access. Because if you don't, you need to be on premises. But then you say, oh no, it's no problem because we reset the application domain once a day. So if that takes half an hour to start and we cache the entire model, that is not a problem. Then you haven't seen the billing from Azure. Because you pay for every data byte you take out of Azure. So if you every day bring home your entire database of 200 gigabytes, you will pay for data extraction that people will never use, never read. So there is hidden costs money-wise, there are costs performance-wise, and everybody says that in your computer environment, you always pay the same. It's a matter of who you're paying to. Are you paying to Microsoft in Azure? Are you paying to your employees because they have to work more? Or are you letting your customers pay by wasting or spending their time looking at hourglasses or nice Macintosh balls waiting for stuff to happen? So can you do this refactoring, recoding? You can go to Azure, but most of the time, the legacy applications or the new applications you create work really fine when you, as a single user, sit there and you have 2 customers, 3 products, and then reality strikes, 10,000 customers. And you say, no, we are a small company. We will never have 10,000 customers. But just wait for it, because if you have that kind of vision for your company, we will only have 5 customers. Either you will be out of business, and fact true, you will never have 10,000 customers. But the risk is that you actually have a good idea, and then you're bought by another company that has 250,000 customers, and your system totally breaks again. Next thing. So, anybody been here? France, skiing? Well, it's not like ski resorts need high availability, right? I've been consulting for an amusement park here in Sweden, where we have this issue that when internet goes down, you cannot. And could you imagine this? The scenario playing out here is you have your family and you have your kids' friends. You invited them to a full day of everything, fun and games. And then internet goes down and you say, okay, sorry, you can't go on this ride because it needs internet to let you in with your ticket. And then you say, okay, we go on this ride instead. Oh, sorry, we can't scan your code because when you were standing in the virtual queue, so you didn't have to line up, that needs internet to get your location in the queue. So sorry, everybody's last in the queue again. So what do you do? Okay, it's 11, let's go eat. Oh, sorry, food doesn't work because you have to pay, and to pay you need your credit card and you need internet. So you're basically standing here in the world's funniest place waiting for internet to come back. That's pathetic. So we need databases on premises. And you have the facts here. Why? Because we are in control of the machines. That sounded like Terminator, right? We are in the control of the machines. But we know where they are. We can touch them. And sometimes when we touch the machine, we feel, oh, this is warm. We need to upgrade. Or something with the cooling fan went wrong. That is impossible to get when you're in Azure because they are somewhere else below the sea. Have you seen that? One Azure data center actually has a container computers below the sea level in the ocean outside of Scotland. That is cool. So we're running stuff in a submarine. And then the second part is we don't depend on anyone. And now I'm going to do some counter arguments again. So let's say that you two guys, you are assisting me as DBAs here. Oh wait, you're on a conference. So who's running the show? It could be a good thing if we have enough staffing. But if people decide to go to a conference, we need to fix that somehow with extra staff or, oh no, sorry, you can't go because you are on emergency computer watch. So that was a good thing for Azure, but that is 3 days a year. So we couldn't have that as an argument. But then availability. We need to have the database, we need to have the local network so we can scan our barcodes, blip, and we come into the attractions. We can count the number of people going. We know when to have service intervals. We know how long the queues are because that is what we're used to. And above all, people can eat, buy stuff. So, this is our biggest problem. And this all relates to competence. And for you who are international, this is a hospital. In Sweden, they are run by regions that are self-sufficient entities under the government. They are running hospitals, taking care of everything. And you would want to have your database on premises. Why? GDPR, right? Can we send the patient information, sensitive information, to Azure? I mean, the discussion even goes, do we want to send the social security number of this patient from Kalmar to Gothenburg? Because we want money for the Gothenburg guy who went to the hospital in Kalmar. But can we really say that he was there with the social security number? Because then we are spreading sensitive information. And then give it to Azure. Yeah, sure. No. So the interesting thing is here, the two second to last questions. Are they competent enough, the cloud providers? And are we competent enough to get it to go into Azure? Because most certainly everybody knows that most countries now has a local data center. We have two, at least now in Sweden, 2 data centers. But people are still scared. Are we competent enough to know what things happen? Somebody checked that little box that says geo-replication, where does it end up? The 2 data centers are main center, Sandviken, backup center in Staffanstorp, just outside of here. So we have a full region that can keep all the data inside our country, unless somebody goes one level further in some box that says, this is more secure for your data. Because then we're sending it to Ireland, Amsterdam, or some other center somewhere, where we have no control. Or do we? Well, that's a matter of our competence. Does anybody guarantee that there will be no data leakage? Yes. The question is if the cloud providers guarantee that there will be no data leakage. I would say they want to guarantee it, but they can't guarantee. Nobody can guarantee everything from data leakage. But the fact is that if you go to the data center, for instance, on Ireland, there are more armed guards protecting the sites than people with administrative passwords. So they're doing what they can to prevent data leakage, but we can always be hacked. Is it okay from a legal perspective to keep data in a data center? Yeah. The interesting question here is it legal? From whose point of view? Yes, but according to GDPR. So, where is the computer? Is the computer in my house? Is it in my neighbor's house? Is it in the provider of my company in Stockholm? And is all the persons working in the Stockholm office working from Stockholm? Or do we have some people connecting with VPNs from, say, Czech Republic? A very famous data leak in Sweden happened like that, where the company in Sweden, Sweden-based, Sweden-owned, outsourced some of their workers to another EU company. So it's a very shady line, and as a tech guy, I'm happy to say there are legal guys that take care of this. I can only advise how it technically works and what settings you should avoid and what settings you must not ever turn on to keep the data as close to you as possible. But legally, it's a jungle. And sadly, there are so many companies, organizations that don't know. And when you don't know, what do? Well, I'd better keep it close to myself. So that is why we're seeing such a resistance to go to Azure or other cloud providers, because we don't know, we can't be sure, and they don't dare promise us that, yes, this is the fact. Finally, with this, we go back to latency, or we go back to availability. Could you imagine the Monty Python sketch? Where's the machine that goes ping? That is the most important machine in the hospital. Or let's say the machine that distributes your sleeping agent when you have surgery. So they enter your weight, your length, your gender, and the machine says, you will have 45 cc's of this per 26.5 seconds. And the machine starts distributing this, measures your breathing, measures everything. And then they have a slight dip in internet connection and the machine says, right now I don't know, but let's put in a couple of hundred more to be safe. Would you want that to happen? No. You would seriously like to have that machine not communicate with anything. And if it has a database where it stores by regulation how much drugs you have given to a patient, if you have the execution log, then you want to have it local so you can keep track of it, know what has happened. So that is another entire story with those machines that go ping or something else. So, that was some samples of projects I've been in, some real-world things that happened, and problems that could arise when you go to the cloud, or problems that can be avoided by doing smart things, or at least using your brain slightly when entering or looking into a project. So, do you have any more questions about things we have talked about? No questions. Then I expect we have emptied all conversation topics about SQL on premises, and I hope you will keep using it on premises as long as you can, because you will get better latency and you will get a feeling that you have control, even if that feeling might sometimes not be true. Oh, question. Oh. Does it take much resources to run the servers if you're a small company? Yes, it does. It takes at least one person knowledgeable about local servers, how they work, how you handle them. But on the other hand, you have to have one person that knows that Azure is working, surveilling that, know how those products worked. And just to be simple here, SQL Server on premises, we have one. SQL database in Azure, we have Azure SQL database, we have managed instance, we can run a VM, we can have Synapse Analytics, we can have Synapse Analytics serverless. So depending on what you want to solve, you can have 5 different flavors of SQL databases in Azure. So when you expand, you need to have more competence and more staff. So administrators will never be unemployed, even if you move to Azure. It's just another kind of admin work. But the small company, 5 employees, tiny data center, yes, then you would probably need to take care of things. Yep. So the question is, would writing your own advanced query, send it through an entity framework environment be better performance-wise than use entity framework to wizard the queries for you? I would answer as a consultant, that depends. In some cases, when you want all the customer information, it makes sense to write a link query from customers where customer ID equals this, select X, and then you're done. But instead, imagine that you need to have just 2 fields of the customer, you need a summary of this one, and you still write select X. Then you either will have a crazy query that returns everything, or you will have a bunch of lazy loading queries that do like that. But there is a trick. So if you use link, you can, instead of returning the regular object model, if you instead decide to return an anonymous new with only the fields you need, then Entity Framework is smart enough to cut the fields you don't use from the query and do an optimization of sort. And then inside the database, you can catch that query and tune for that specific case. So no, I wouldn't say that you necessarily need to write your own queries. Go on, use the framework. But again, use your brain. Pick the things you need, not fill entire objects just because you can. Yes? SQL Server always encrypt is a viable way, because that's when you have a certificate on every application and data is encrypted everywhere. So that is one solution that you can do, that you can trust. The problem with that is that you can't use regular troubleshooting tools to find the information or get other clients to find it. So in one of the projects we had, we solved this, that the secret information, so to say, was stored on premises. And then the anonymized information with just pointers to the secret stuff was online. So when you needed to get secret stuff, you had to do a secondary lookup on the secure system with the full logging. And the statistics and everything was openly available, but of course closed as far as possible in the Azure environment. Cool. Yes? The question is, could the latency go down? Yes, it can. My latency, the chart that I showed, is based on the public internet access to Azure environments. And you can get to your company an express route that is a more direct route into Azure. That reduces latency quite a bit. But we are still limited by some annoying facts like the speed of light and things. Good. So I hope you enjoyed the database talk as much as I've enjoyed talking to developers. Thank you.